This is an introductory presentation on little bits. First, we're going to do a review of electrical circuits. Electrical circuits are a lot like water. Plumbing system in which water circulates, except discharging of water outside the closed pipe system is not allowed in this scenario. Three major terms: voltage. Voltage is a force that pushes the current through the circuit. In this picture, it would be equivalent to gravity, because gravity is pushing the water along. We use a voltmeter to measure voltage. Measuring voltage, there are different cells produce different voltage, such as a AA battery produces 1.5 volts versus a 9-volt battery, which obviously produces 9 volts. All right. Our second major term is resistance. Resistance is the friction that impedes flow of current through the circuit, such as the large rock-like boulders in the river are getting in the way and causing resistance to the water flow. And our last major term is current. How you should be thinking about it is current is the actual substance that is flowing through a wire. This is the electrons, okay? Electrical current consists of charged particles, electrons flowing through metal wires like water. Current consists of water molecules flowing through hollow pipes, right? Just to recap. And we measure current in amps, as well as we measure volts for voltage, and this is the same thing as measuring water. You can measure water, gallons per minute, etc. All right, then with wiring, this wouldn't connect because we need to have a negative to positive connection. This wouldn't work either. And finally, we get to this connection. This is a closed circuit. If we do not, we have a broken circuit. With little bits can be somewhat deceiving at first glance. When you look at them, it looks like the energy is only flowing in one direction, but if you actually take apart each bit and take a closer look, you'll notice that the energy is flowing, okay? You have energy flow, all right? We have two major types of circuits. We have series circuits and we have parallel circuits. The major difference is that in a simple circuit, the energy has to flow through the bulb onto the next one. If one bulb goes out, it breaks that circuit and the energy cannot flow on. But in a parallel circuit, it can move on even though the bulb is broken, because it can pass on to the next as many paths. Now, little bits. This is your front view of your little bits. You have your back view. You have your side view. And what I want you to notice is you have your magnetic connectors and your conductive connections right here. All right. If you would like at this time, you can experiment with these little bits. Now, we're going to be looking at light sensors. Here's a few questions. We're going to review these. How do humans sense light? Obviously, we use our eyes, and we're going to be making a comparison of our eyes to light sensors. And looking at stimulus sensor coordinator effector response. All right. And some example of light sensor engineering systems. We have cameras, sensors that turn lights on when it's dark, etc. From stimulus to response, as we use a stimulus is a light from, we notice a wasp, the sensor is the eye that senses it, sends a signal through our nervous system, which is our coordinator. The coordinator makes the decision how to react, and then commands the legs, which is the effector, to run. Okay. Sense of light. How light will go through your eye, and we make a decision. And what we're going to be looking at is how light is sensed by our eye. Our anatomy of the human eye. Let's look a little bit more at this. We have light goes through the lens, And behind the pupil focused image on the retina. The image is upside down, but the visual cortex in the brain helps you identify the image. The retina is filled with light-sensitive cells called rods and cones. Rods identify shapes, cones identify colors. All right. Now, our eye equivalent in electronics is the light sensor. All right. And what I want you to notice on the light sensor is that you have sensitivity, where you can tighten or loosen this sensitivity. You also have the actual sensor part itself. Sometimes this is a photoresistor. Photoresistors detect light as well as they do what a resistor does. They impede that flow of energy. And then you can switch it from recognizing light or recognizing dark. Light sensors are made using electronics, excuse me. Electronics enable a sensor to distinguish between the different intensity of the light. This looking for brightness is where it's detecting intensity. All right, this is a video of the project you're going to work on. These are the parts you're going to be using for your first project. You use an LED with, here's an example of that schematic. Schematics are like diagrams or blueprints for electronics. You're going to be using a power source, which is a 9-volt battery. Notice the on-off switch. You're going to be using wire, which helps make extensions, and a DC motor. And what I want you to point out on the DC motor is the drive shaft. It is literally shaped like a D, and this allows you to connect things. And I encourage you to connect different materials to this. And then we're going to be using our light sensor. With your project parts, we're going to connect our project parts here with your, starting off with your power. You have your on-off switch. And we're going to connect our wire. And then we'll connect our light and dark mode. And we'll start off with light, which is fine, or dark. It's up to you. And we'll have our, this will be step 3. Connect our next wire. And then we're going to connect our LED. And then we'll connect our DC motor. Okay. What I would like you to do is try changing the light and dark mode. Put your finger over the light sensor. Here's some examples. Turn the lights on, turn the lights off, and see what takes place. Okay. Now we're going to move on to sound. What is sound? Sound is made of sound waves or air vibrations. Louder sounds produce larger vibrations. Higher pitched sounds produce more frequent vibrations. How do you hear a song or any other sounds? Pressure vibrations in the air are perceived as sound. A speaker causes an air to vibrate in the pattern, which is the waves below, shown in the diagram, and your ear picks up the sound. From your outer ear, these vibrations pass through your ear canal and reach the middle ear. Okay. Now, the human ear anatomy. We'll be doing a review of this. The eardrum vibrates 3 small bones in the ear in turn: the hammer, anvil, and stirrup. The stirrup passes the vibration to a coiled tube in the inner ear called the cochlea. The cochlea is filled with fluid, and the cilia in it are connected to the auditory nerve. They pass it along to the auditory nerve. The auditory nerve carries a signal to the brain. Now, here are 2 light buzzer. It's our next project you're going to be doing. Please watch these, and then after you're done, please come back. The parts you're going to be using is a Bargraph, a bright LED, a button, a buzzer, power, and wire. Let's go over these. Bargraph has 5 LEDs, and what's great about this is it shows the strength of the energy flow. The higher the flow, more LEDs are lit up. Less LEDs are lit up. You'll be using the bright LED again. You're using a push button. Push button is like an on-off switch. If the button is pushed, it allows energy to flow through. If it is not, then you can actually see that on the diagram right here, the switch area. All right, then we're going to be using a buzzer. The buzzer is loud. All right, have fun with that because it does somewhat make an annoying noise. All right, our power and wire. Okay, first step, you're going to cut a hole in a cup. Next, that hole you'll run the wire through. Then you're going to connect your buzzer to your wire, and then you're going to follow this up with an LED. Then connect your bar graph to that. And next we're going to tape or place or attach our buzzer LED bar graph assortment inside. Next, you're going to run that wire and connect your button. Here's a better view of that. And then attach your button to your power source. And then you can attach it to the top of the cup in some way, and you're finished. And you can try that out. If you watch the video, you'll notice that the cup is being used as like a megaphone to amplify the sound of the buzzer. All right. And it gives a great like light ambiance with the lights flashing as well. All right, and here's a review of those steps. All right, well, this is a recap. In our upcoming video, you will be making a flashlight, which you'll need like a paper towel roll and a cup and rubber band. All right, thank you, and this has been a short introduction into Little Bits.